In the last lecture, we had briefly met the turtle module of Python. You may remember that this is something which allows you to draw nice figures on a screen. Of course, all we have done so far is draw a square. But let me just point out that that is just the beginning of what we can do. Now, at the very beginning, we have to start the Python interpreter. And as I said before, I have started the Python 3 version, Python 3.6.9 for my computer. Most of you, if you have installed Python recently, will have an even later version of Python, something like 3.8.1 or something. And on your machine, if you are using a command like this, most likely you will have to just say Python and not Python 3. But now, be that as it may, I have opened the interpreter, and then if I want to use a turtle module, this, remember, is a mantra we have to use, from turtle import star. And we have done that. Now we are ready to use the turtle module. Let's use a reset function from the turtle module, which we briefly met in the last lecture. Of course, what reset is supposed to do is it's supposed to clear out whatever we have drawn and return the drawing head, the turtle, back to the center where it is ready to start all over again. I'm just using the reset at the very beginning, even before drawing anything, simply so that I can bring the turtle and the canvas where the picture is being drawn into view, and I'm moving it to one side so that now I can have a nice view of both what I am typing and the turtle. And another function from the turtle module that we had used the other day is width. Function, in case you are wondering, is simply a bunch of arguments put in one packet so that I can call them with one single name, and most functions take arguments. Here, for example, I am giving the width function an argument 3. What that means is, after this function is executed by just hitting the enter here, the width of the pen which the turtle uses to draw on the canvas, in case you didn't figure out already, the canvas is this white thing that you have here on which drawings are being drawn, and the pen width has been set to 3 times wider than usual. Okay, and just to recapitulate briefly what we did last time, we carried out these set of commands, forward 100. Oops, as you see, there's an error, but the error is easy to understand. In my hurry to type, I forgot the R in the forward, and notice Python is giving me an error which we also met in the last lecture. It's telling me that I have made a name error. It does not know the name forward. Of course it doesn't. The name really is not forward, it's forward. So let's type it correctly now. But I will urge you to think about error messages. When Python gives an error message, it usually is very clear about what has gone wrong, and once you start writing your own code, it will be great if you just looked at the error messages. You will make errors from time to time, every programmer does. Rather than get disheartened by the error messages, look at them, try to learn what has gone wrong from them. Now, let me just remind you that this is what we did. Forward 100, then we used right 90. Notice that both forward and right are functions, and they're being called with arguments. The arguments respectively mean by how much is the turtle going to move forward, and for right, the argument is by through how many degrees is it going to turn to the right. And now what I will do is just repeat this 3 more times, 4 times in all, and I've ended up drawing a square with the turtle back exactly where it pointed earlier. Of course, that's because it has turned right through 90 degrees 4 times, meaning that it has turned through a total of 360 degrees, and 360-degree rotation is of course no rotation at all. It's back pointing the way it was at the beginning. So this is what we had done earlier. So can we learn anything from just drawing a square? Actually, it turns out that we can. Well, just to give us a level playing field or a clear playing field, let's just use the reset function again, and let me set the width back to 3 once more, and let's try to draw the square once again, but this time with a bit more finesse. What kind of finesse do I mean here? Notice that what I have done is I have repeated the same commands forward 100 and right 94 times. Now, repeating the same command over and over again is exactly the kind of thing a computer is best at. That is one thing where computers are far better than humans. Humans usually tend to get bored if you give them the same thing to do over and over again. Computers will happily do that as many times as you want, not just 4 times, maybe even 4 million times. Right now, of course, we only need to repeat this pair of functions, forward 100, right 90, 4 times. These are not functions, of course, these are function calls. I've called a function which has already been written for me. I've called the function, that's the technical way to speak about it, with arguments 100 and 90 respectively. Now, I want to do the same thing 4 times. That is what is called a loop. A loop which will run 4 times, and every time the loop runs, these 2 function calls will be executed. So how do I run a loop 4 times? Now in Python, there are several ways of writing loops, but the kind of loop that we want here, a kind of loop where we know exactly how many times we are going to run it, is best done by using what is called a for loop. So we start by the standard format for this. You start with for, then I have to give the name of a variable. What name I give does not matter. All that matters is that it should be a genuine, honest to goodness variable name, and for our purpose now, even something as simple as I will work. So the command that I am giving starts with the keyword for, then you have a variable name I, and this is very important that you say in. So for I in what? In something which has 4 pieces. Now things which come in pieces have a technical name. They are called iterables. Why are they called iterables? Because you can iterate over them. What that means is essentially you can run a loop taking them piece by piece. So far the only thing that we have seen in the last lecture which had pieces is a string. A string, of course, is made of many characters. I used my name, my own name, as an example in the last video, and there, of course, I had used a string, started with a quote, then wrote A-N-A-N-D-A, ended with a quote. That would be a string with 6 objects, the character A, then N, then A, then N, then D, then A. Now, if I want to run a for loop, I can run a for loop using a string, because a string has pieces, and all the for loop wants is that the variable which I am using right after the for keyword, that has to take values which come from those pieces. So now in this case I want to run a loop 4 times, so I will just use maybe a string like this, A, B, C, D, a string which has 4 pieces, A, B, C and D, and then I end the line, the top line that I have to write here, with a colon. Now this is something you have to bear in mind. What I am writing right now is something called a compound statement. It's one single statement but made out of many statements, not just one single simple statement like forward 100 or right 90 or reset bracket that we have been writing so far. This is our first compound statement, a single statement which is made out of many statements. Now in Python, the basic rule is this: every compound statement has to begin with a header line, and the header line can take different forms depending on what kind of compound statements you are writing. If you are writing a for loop, it has to be of this particular form. It has to start with the for keyword, then you need a variable name, then you need to write in, which is again a keyword, and finish with something which has many pieces, some iterable. So far the only one we know is a string. So for I in quote ABCD, and what is very important is that the header line has to end with a colon. So that's the headline done for a compound statement. Notice that now that when I hit the enter, something new has happened. I do not have the prompt back. I do not have this triple greater than prompt back. I have a triple dot. And the triple dot means what triple dot means in ordinary literature. It means continuation. It means go on. So from the structure of what I have just typed, the interpreter has recognized that I have not ended. I've just written down the header line for a compound statement, and after that I have to put in the body. But this next thing is also very important. So one important thing about the compound statement you have already seen: it has to have a header line, and the header line has to end with a colon, and then it has to have a body. In this case, the body simply are made out of the statements which will run every time the loop is executed. So for I in ABCD is a loop where I will take A, B, C and D. These four values in succession will run 4 times. What will happen each of these 4 times will depend on what I write in the body. And this is again a very important rule in Python, that the body in a compound statement has to be indented in. In the last lecture we said that at the beginning of a statement you cannot put a white space. If you put a space at the beginning, it's going to give an error. That is true as long as you're writing a given statement. But if you're writing a compound statement, the header line has to be written without any spaces in the beginning, but the body has to be indented inwards. By how much? Doesn't really matter, but it has to be the same amount every time. If you have 3 lines in your body, you cannot indent one with 2 spaces, another with 4, another with 8. All of them have to be indented exactly the same amount. There's a catch there though. If you have a compound statement inside the compound statement, then the body of the second compound statement will have to be pushed further in. But at a given level, all indentations have to be equal. So in this case, I have only 2 things to repeat every time the loop runs. I have to put in forward 100, right 90. So this is my for loop. I have just written both lines. After hitting the indent both times, I have written both the function calls, and of course it's still giving me the triple dot prompt, because it still doesn't know whether I have ended. After all, the body of the loop may have many more statements. So how does the interpreter know that I have ended? I will hit the enter key without typing anything else from the very beginning. Right now it's right after the prompt. If I hit the enter key from here, it's going to know that I have written the full loop, and because I'm in the interpreter, I have given one complete statement, and the statement is going to now run, which means the loop is going to execute 4 times. Let's see what happens. I hit the enter. See, what has happened is that rather than having to type forward 100 right 90 4 times over, I'll just use the loop to do this for me. The loop runs 4 times. Why does it run 4 times? Because the string that I used, the iterable that I gave here, the string, has 4 entries, A, B, C and D. So I takes the values A, B, C and D in succession, and each time it takes a new value, the body is executed. So forward 100, right 90 is what happens. Just to show you that this is really what is happening, that I really takes the values A, B, C, D. Let's do this all over again. Remember, the reset is just to clear the screen, but unfortunately what it also does is that it sets the width back to 1. Because we want to see more prominently what's happening on the screen, I have to set the width back to 3 by using the width function call. Now what I will do is I will repeat the loop again for I in ABCD, forward 100, right 90. This is what we did before. But now I will add one more function call. I will use a print function which we met the last lecture to print the value of I. So this particular loop will do 2 things. Will actually do 12 things, because it's run, or rather 3 things in each pass. It's going to make the turtle move forward by 100 paces, turn right to 90. At the same time, it's also going to print the value of I on the screen. So let's see what happens. Once again, remember, how does the interpreter know that you have done writing the loop and now want to run it? You hit the enter key without moving the cursor from the beginning of the line. And notice, of course, what the cursor has done is exactly what it was doing before, but at the same time, it has printed out, the loop has printed out the values of I. So I has taken the value A, the B value B, the value C and the value D, as I stated. So can we use this to draw, say, a hexagon? Of course I can. All I have to do is bring in a 6-element string. It does not really matter what the string is, as long as I know that it has 6 elements. I could even use my first name. Anando has exactly 6 characters, so I could use that here. But now I have to remember one thing. You have to go forward maybe by 100 units every time. That just tells you how long your side of the hexagon is going to be. But because we are trying to draw a hexagon, how much do I have to turn? The answer is simple if you realize that at the end of drawing the hexagon, I must be pointing back the same way as I started, which means the amount by which I turn has to be 360 degrees. So every time I turn, I have to turn right. Of course, I could have gone left using the left function, then the hexagon would have been drawn the other way. But the amount of turn is not 90 degrees, it's 60 degrees. Okay, and there's no point in printing I again. You have already seen what's going to happen. So let's just execute this loop by hitting the enter key. And we are done. We have drawn a hexagon. Now you might be wondering, suppose I wanted to draw a 12-sided figure. Fine. For that I will need to write a string with 12 characters. A, B, C, D, E, F, then G, H, I, J, K, L. It's okay, you can do it, but very often you may have to draw or may have to use a loop many more times. Writing a string with that many characters becomes quite a lot of bother. So instead of a string as an iterable, we could use something else here, and that something else will actually be much more useful for us in the long run. Not much more useful, strings are also very useful, but this new iterable is something which is going to be very useful. It is called a list. So what is a list? A list is something you write. Okay, I'm not going to use a name list for it. I will use just the name li. I won't use the name list simply because list is a reserved keyword in Python. It does certain things. And if I name a variable list, then I cannot use the list function, which I actually need often. So to write a list and store it in the variable li, that's why I'm using the assignment statement from last time. Remember, the equal to here is an assignment. It says whatever is on the right hand side of this equal to, find out what it is and then push it into a region of memory which is labeled by the name li. If you want to write a list, what you have to do is start and end not with quotes but with square brackets, or sometimes we call them third brackets. But remember, you have to start and end with the beginning bracket and the ending bracket. Unlike for strings where you have to start and end with the same quote. Here, you start with the left third bracket, end with the right third bracket. Inside that, you have to put in 6 numbers. 6 because we want to draw a hexagon. And end. So you write those numbers separated by commas. Here I've written 1, 2, 3, 4, 5, 6 and ended with a square bracket. So now I have a list which has 6 elements. So earlier we had strings which had pieces. Now I have something else which have pieces. The list li has 6 pieces and each of the pieces are the numbers 1, 2, 3, 4, 5 and 6. Let's use the list li to draw the hexagon. Of course, we need to reset once again to clear everything on the screen. I have to set the width back to 3 so that you can see this more clearly. And now I'm going to use a for loop once again for I in, but this time instead of using the string ABCDEF, I will use a list li. I could have written down the square bracket 1, 2, 3, 4, 5, 6 here in the header line of the for loop, but that gets cumbersome. Since I have stored that list in the variable name li, after that I can keep on referring to whatever is in li by the name itself. So for I in li, then I call the function forward 100 to move forward by 100 units. Then I turn right through 60 degrees. And now, you see, this is exactly what I was talking about. The hexagon has been drawn. Why? Because I now took the values which are in the iterable, the list li. Both lists and strings are iterables. They have pieces in them and you can iterate over them. This is exactly what we have done here. The string served as the storehouse from where the I got its values in this loop, and here li is serving as the reservoir from which I will get its values. Just to illustrate that once again, let me just repeat the same set of commands. Notice that the indentation, of course, has to be maintained perfectly. And now I add another indented statement. Let's just print I to see what values I takes. So now when I hit the enter key, the loop is going to run 6 times because li has 6 pieces and I takes those values in succession. And you can see that immediately when I hit enter. Because every time the loop runs, that is the cursor has moved, the line has been drawn and the turtle has turned. After that it's printing the current value of I. So I is 1, 2, 3, 4, 5 and 6. Okay. So lists and strings are both iterables and you can use them to actually run a for loop. Later on you will see many powerful things you can do with the for loop, and the fact that you can run the for loop with any kind of iterable actually will become very, very useful. Now that we have kept on saying that strings and lists have pieces, can I look at the individual pieces separately rather than in the for loop? Of course, in the for loop, I takes every successive value of li, and I can use print I to show what value it has taken. But can I see what is inside a list or a string, or the pieces inside the list or a string, without taking recourse to a for loop? The answer is I can. I can index or look at different elements inside a string or list. So let's start with this string. This s is a variable name which right now is storing a string. And in case you are wondering with why did I type APQLE, the answer is simply because I wanted to be able to distinguish each character in the string. That's why I did not type APPLE. So now, how do I look at the individual elements in the string? For that, you have to call the string, or rather, calling is a word which you reserve for functions. So you call functions, name the function, follow it up with round brackets, inside you give the argument. For strings or other iterables, the standard thing is you index the string. That's what you say. And the way to index is name the object, in this case the string s, follow it up with the value of the index which you want to look at in square brackets. So maybe I can do this. So this is going to return to me, give me back the 3th element of the string s. Of course, 3th is not what you usually call things. In English, it sounds odd. But let's just see. If I call the 3th element, I am getting L. But isn't that the 4th element of the string? Yeah, so it is. So why is it that s square bracket 3 gives you L? The answer lies in the way computers count, or strictly speaking, programming languages count. Most programming languages start counting not from 1, the way we learned to count when we were children, but they start counting from 0. So we, instead of the first, second, third, fourth, fifth element of the string, what we really have is a 0th, 1th, 2th, 3th, 4th. The reason why I am using strange sounding words like 1th, 2th, etc., instead of just saying first or second, is that the 1th element really is not the first element of the string in the standard English sense of the word. It's actually the second element of the string. The first element of the string is a 0th. So I will try to keep on consistently using this kind of language, 0th, 1th, 2th, etc., knowing fully well that that's bad English, simply because I want to keep on reminding you that the counting starts from 0. So the 3th element of S is actually, this is the 0th, A, 1th, 2th, 3th is L, as the interpreter has told you. Well, what is this 0? Let's see. Was S 4? Let's see. 4th element, the 5th really, but it's in our indexing style, it's actually the 4th. S5, well, if you try to find out the 5th element of S, you're getting an error. And the error is simple, it's saying index error, it's saying string index out of range. Why? Because for a 5-element string like S, the index values can only be 0, 1, 2, 3 and 4. No other values are allowed. A value bigger than 5 will simply give an error. Well, this may be a bit strange, but a negative index, a value less than 0, will not necessarily give you an error. S minus 1 will actually give you E. S minus 2 will give you L. Just remember that this is what S is. So it should be pretty easy for you to figure out what S minus 1 really means. If you are using a negative index, counting starts from the back. So S square bracket minus 1 is actually the last element of the string S. S square bracket minus 2 is the element before the last element. S square bracket minus 3 is Q. S square bracket minus 4 is P. S square bracket minus 5 is A. S square bracket minus 6 will be an error, because start counting from the back, you do not have a sixth element. So you can count both from the beginning by using positive indices and from the back by using negative indices. What about lists? Remember, this was our list li, and here indexing works exactly the same way as for strings. Li square bracket 0 is the 0th element, which of course is 1. Li square bracket 5, this one is legitimate because my list now has 6 elements, so its indices actually go from 0, 1, 2, 3, 4 up to 5. Li 5 is the 6th element, 5th but 6th. That's 6. Li 6 will of course give you an list index out of range error. Li minus 2 will give you 5 because you're counting from the back of the list, and so on. So in that way, strings and lists are very, very similar. There's another thing which is very important. There is a function called len, whose argument can be objects which are defined, and if I supply it with the string S, it's going to tell me how many elements there are in the string S. I supply it with the list li, it is going to give me how many elements there are in the list li. So this works for all iterables, all things which come in pieces. Strings and lists happen to be the most important of them, but there are others as well. And when I use this, I get to know the length of each of these iterables. Just one reminder, the indices go one short of the length. Why? Because the counting has started at 0. So you exhaust 6 elements, say for li, at index 5. Okay, so in this sense, strings and lists are very similar. But they are also quite different in some respects, and most different perhaps in this respect. Can I do this? Li square bracket 0 of course is 1. But suppose I want to change it to say 11. Can I do that? Well, I'm trying to do that. Li square bracket 0 is the 0th element of li. I'm trying to assign that the value 11 by using the equal to sign. I hit the enter. The computer is not complaining, which means almost certainly what I am doing is legitimate. It has been done. So let's see what has happened to the list li. Notice the list li has now changed. The 0th element is no longer 1, it's 11. So this really has worked. I've changed the element, a specific element from li. Well, now that we know that, let's try doing this with S. Instead of the wrong spelling, which I actually deliberately put in so that all the characters in the string will be different, let's just change the Q, which remember is S2. Let's just change that to P. Now, if I did this, I would have got an error, because Python would have tried to calculate what this P is. It will think P is a name of a variable, and then it will complain. Okay, let me show you. It is complaining. It's giving you a name error. It's saying the name P is not defined. It does not know what P is. But what I really meant was this. I want to put the string, single element string, which can be often also called a character, but it's really a single element string. I'm trying to put this single element string in the 2th position of the string S, so that after I do this, the string S should become APPLE, the correct spelling. Now we have a rude shock. I'm getting an error message. It's saying type error, and the error is str object. No prizes for guessing what str object is. The name is short, of course, for string. Does not support item assignment. What I did with list, I assigned an item of a list with some other value, is something I cannot do for a string. In a string, you cannot change individual pieces. That's exactly what this message is saying. The string object, str object, does not support item assignment. Now, there's a technical, complicated sounding way of saying this. We say lists are mutable. You can change them once they have been created. Strings, on the other hand, are immutable. You cannot change them once you create them. So that is one very big difference between lists and strings. However, despite those differences, and there are many more, we are going to meet them over and over again in the next lectures. The similarity between lists and strings, of course, is that they can both be used as the iterables for a for loop. But it may seem again quite complicated. If I wanted to draw a 12-sided figure, would I really write a string with 12 characters or a list with 12 numbers? You can do that. 12 after all is not such a huge number. But if you wanted to run a loop 1,000,000 times, would you actually type 1,000,000 maybe numbers, one after the other, in a list? That would be too much of work to do. So Python actually supplies you with a way of doing this much faster, and that's called the range function. So this is an iterable object of a very special kind called an iterator. We are going to describe what this is in a big way later, but for the time being, just think of range 6 as something which produces a list. What list? The list of indices of a 6-element iterable. What are those indices? 0, 1, 2, 3, 4 and 5. Let's draw the hexagon again. Of course, I've forgotten to clear out my screen. So what you will see, okay, let's just draw a slightly bigger hexagon so that the path faced by the turtle now will be slightly different. You can see the new hexagon being drawn. And just to emphasize that I really takes those values 0, 1, 2, 3, 4 and 5, let me just print out the value of I as well from within the loop. And now I hit the enter key. The hexagon, of course, is completed. It's a bigger hexagon than before. And you have got the index values. I takes the values 0, 1, 2, 3, 4 and 5. Now, if you are using Python 2, that is the previous version of Python. Typically Python 2.7 is what many of you may have in your computer. Then range 6 will actually produce a list. It will produce a list with entries 0, 1, 2, 3, 4 and 5. A list is just what the name means. It's a list of objects placed one after the other. Begin with a square bracket, end with a square bracket, put commas in between to separate different elements. In Python 3, however, range does not really produce a list. It produces something else. But you can change it to a list simply by using the list function. Now, using the list function is not necessary if you are using Python 2.7. It's Python 3 because range 6 produces something which is not really a list. Why? We are going to explain that somewhat later once we understand a bit more about the way the computer works. But because it produces something else which somehow has these elements 0, 1, 2, 3, 4, 5 in them, I am converting that into a list by using the list function. And notice the resulting list is of course exactly the list I talked about, 0, 1, 2, 3, 4 and 5. So suppose I want to print the first 1000 numbers. Instead of typing out the name of all those 1000 numbers in a big list, what I can simply do, so range object returns the number 0, 1, 2, 3 and so on. In succession, I takes each of these values. I print I and hit the enter key. Of course, 1000 numbers will scroll off the screen. But as you can see the end and you have printed all these numbers. Remember, I takes the values 0, 1, 2, 3 up to 999 because that will give you a full list of 1000 numbers. Not 1000. So that's why this is ending at 999. If I scrolled back, I would be able to see that a while ago it was printing smaller numbers all the way down to 0. So 0, 1, 2, 3 that was being printed. Okay. So in general, if you want to run a loop a fixed number of times, say 1,000,000, the best thing to do, the easiest thing to do would be to use a header line for name of variable in range 1,000,000 or 1,000 or 20,000, no matter number of times you want to run the loop. So as I said, if you want to run a loop a fixed number of times, the best thing to do would be to use the for loop. In the next lecture, we will see how we can use some more fancy ways of doing the same kind of thing. In the process, we will learn a lot more about the way Python works and the way you can use various Python objects to control your program. Bye for now. See you next time.